Alright guys, so this next one's on trigonometric functions with special angles. So off to the left I have a 45, 45, 90 triangle pulled up and a 30, 60, 90 triangle pulled up. When you have a 45, 45, 90 triangle, it's an isosceles right triangle. So these two sides are going to be congruent. That's why they both have the same letter A. And then the hypotenuse is going to be A times the square root of 2. When you have a 30, 60, 90 triangle, the shortest side is going to be A, the longer leg is going to be A times the square root of 3, and the hypotenuse will be 2 times A. Now, sometimes we have to decide what A is going to, or we have to solve for what A is going to be. So let's look at this example they gave us here. I know that this is an isosceles right triangle because both of these letters are X, so I know that X is 45 degrees. Now, if you did this on the unit circle, the 45-degree angle is going to be at pi over 4. So we actually need to write this in terms of radians. Now, we need to solve for A over C. We don't know what the letters, or I'm sorry, what the numbers value of these are, but I know that this over that is going to be the same thing as A over A square root of 2. So our A's are going to cancel, and I'm going to be left with 1 over the square root of 2. But because I cannot have square roots on the denominator, I have to rationalize this, so I'm going to get square root of 2 over 2. Alright, now tangent of x, either way, it doesn't matter which x we're going to pick, it's going to be A over A, which is just going to be 1. So anytime you're taking tangent of an isosceles triangle, you're going to end up with 1. Alright, so let's see. We've got another isosceles. I know that because it's got pi over 4. So I know that x is also going to be pi over 4. K is going to be my A value. We can solve for A by doing, I know that 2 has to equal A times the square root of 2. So I can solve for it by dividing by the square root of 2. But like we had to do in the last example, we have to rationalize. So we end up with 2 root 2 over 2, which just reduces 2, square root of 2. And then sine of pi over 4 is going to be our opposite over our adjacent, or sorry, opposite over hypotenuse. So this will be root 2 over 2. I'm just going to double check this last one. It should be 2. Yeah, okay. Again, we've got another isosceles. So x will be pi over 4. Those are always going to be our degrees of the angles when we're talking about an isosceles. K is going to be 1 divided by square root of 2. But we have to rationalize, so we end up again with root 2 over 2. So sine is going to be root 2 over 2 divided by 1, which is just root 2 over 2. Alright, let's see if they can give us another there we go, this is one of 30, 60, 90. So this is a 30, 60, 90 because it itself is not isosceles, but they put two triangles together to make an isosceles triangle. So I know that this value over here would be 1, and this would be 1. This value right here is going to be half of 1, so I know that B is going to be 0.5, or 0.5. And I know that A is going to be 0.5 times the square root of 3, and I'm pulling that straight from my 30, 60, 90 triangle, my special right triangle. Now, the larger angle is going to be next to the smaller side, this symbol right here. That's going to be your pi over 3. And the smaller one is going to be pi over 6. So let's take tangent of theta. So tangent of theta is opposite over adjacent. So we want to do 0.5 divided by 0.5 to root 3. That reduces to 1 over 1/3, but we cannot have a rational in the denominator, so we end up with this. Okay. Good luck. Go practice on your own.